Let's talk about a tool you probably have open on your computer right now, Microsoft Excel. Today, we're going to see how you can push this everyday tool to its absolute limits to do some seriously powerful industrial-grade engineering.
And that brings us to the big question. Can you really, truly model the incredibly complex inner workings of an entire chemical plant using only a spreadsheet? I know, it sounds a little crazy, but stick with me, because the answer is a huge, resounding yes.
Okay, so first things first, let's set the stage. To really appreciate how clever the solution is, you have to understand the sheer scale of the problem we're trying to solve.
Now, this is not some simple little textbook problem. We are talking about a medium complexity acetic anhydride plant. That means 14 major pieces of equipment, 9 pumps, 5 storage tanks, and, this is the really tricky part, 7 interconnected process cycles. It's this giant, complex web where everything affects everything else. One tiny mistake can throw the whole thing off. So how on earth do you manage all that complexity without shelling out for some super expensive, specialized software? Well, the key isn't about finding some new, shiny tool. It's about having a brilliant new way of structuring the tool you already have.
And the entire secret is in the workbook's architecture. Look at this. Instead of one giant, messy spreadsheet, this is a beautifully organized, modular system. All the core data, physical properties, costs, it's all centralized in one spot to prevent errors. And then, every single piece of equipment gets its own dedicated sheet for its calculations. This methodical, clean structure is exactly what makes the complexity manageable.
All right, that's the high-level view. Now let's zoom in and see how this actually works in practice. We're going to take a closer look at one of those modules, the acetone column, to really get into the nuts and bolts of the engineering calculations that make this whole thing tick. And this right here highlights the core challenge. You see, calculating the flow of materials, what engineers call the mass balance, that's pretty straightforward. It's a system of equations you can solve one after the other. But the energy balance, calculating temperatures and heat duties, oh, that's a whole different ballgame. That requires solving a system of 7 equations that all depend on each other. You can't just solve them in a simple, straight line.
So, how do you solve those tangled, non-sequential problems? This is where a deep mastery of Excel stops being just a skill and becomes a real professional advantage. It's about using a powerful built-in tool that, honestly, a lot of people don't even know exists.
And that tool is the Excel Solver. You should think of it as a secret weapon for engineers and analysts. It's an add-in that's specifically designed for these kinds of messy problems, where you have a target outcome and a whole web of variables. It just intelligently and repeatedly changes things until it finds the exact solution that makes all the equations happy at the same time. And if you want to see just how powerful this thing is, take a look at the extinction tower. This single piece of equipment involves a system of 11 interconnected equations that have to account for material flows and chemical reactions happening at the same time. I mean, trying to solve that by hand, it would be an absolute nightmare. But with Solver, you just tell it what you don't know, you set your targets, and bam, it finds the precise values that make the whole system balance. It's just an incredible display of computational power.
Okay, so now we've got a complete working engineering simulation of the plant. But that's only half the story, right? Now we get to the crucial next step, translating all of that technical data into a solid financial analysis. This is where the engineering really meets the business.
And because every piece of equipment was modeled on its own clean sheet, we can now just roll up all those individual costs. The spreadsheet does all the heavy lifting. It calculates total equipment cost, the total plant investment, production costs, revenue, and ultimately the key performance indicators that tell us if this project is even worth doing.
And this detailed analysis gives us the hard numbers we need. First up, the total investment needed to actually build the plant, calculated right from our engineering specs.
And from that, we can figure out the project's core profitability with one of the most important metrics in finance, the internal rate of return, or IRR.
And finally, the payback period, which tells us just how quickly we're going to recoup that initial investment. All 3 of these critical business metrics, all derived from a single, incredibly powerful Excel model. So, when you step back from all these complex calculations and all these numbers, what's the big picture? What's the real takeaway from this whole exercise?
Well, the key insight is this. You don't always need the newest, most specialized, or most expensive software out there. A lot of times, real power comes from a deep, creative mastery of the fundamental tools you're already using every single day.
And that really just leaves us with one final question to think about. We looked at a chemical plant today, sure, but this principle is universal. So ask yourself, what complex problem in your own work, in your own industry, could you unlock, not by buying a new tool, but by achieving a deeper, more expert understanding of a tool you already have? Thanks for joining me.